Hello everyone. Today we'll be discussing about a concept that is minimum time required by an object or a car to turn by 90 degrees without changing the magnitude of its velocity at the initial moment and the final moment. So the required variables are that there is a floor whose friction coefficient is mu, and here's the shaded one is a wall. So that the car does not crashes with the wall, it has to turn its velocity by 90 degrees. Initially the car is approaching perpendicular to the wall, and finally it goes parallel to the wall. Then you have to analyze the trajectory of this path so that the car turns exactly by 90 degrees in the minimum time. What is the key idea behind this problem is basically some vector geometry. Suppose here is the initial velocity v. Finally, the velocity should be v vector like this. Now we know that vf vector minus vi vector is equals to integral a vector dot dt. Since this is the vi vector, I'll just turn it. This is now the blue one represents the net value of integral a dot dt vector. We know that a is constant, which is equals to mu g, and this is the maximum acceleration that can be attained by the car. Now integral a dot dt, maybe a dt's may form some vector like this, but the resultant will be the bigger straight line, that is blue vector. So to minimize the time, what I will do is that a vector will be maximum and directed towards the v final vector from the tail of the minus vi vector, and it will be mu g. So mu g into t is equal to root 2 v. From here we'll get minimum time is equals to root 2 v by mu g, and that is the required answer for the minimum time. One may ask about the trajectory of the path. So just once visualize that here it's moving at some velocity, initial velocity v. Now the acceleration, direction and magnitude both are constant. It does looks like a projectile, so the path will be actually a parabola. And we can also find the value of the minimum distance, that would be, sorry, minimum distance from the wall. If the initial distance is d when the acceleration began, it will be d minus mu g by root 2. Sorry, it will be some, let this distance be x, that is the maximum distance covered along the x-axis. So the distance will be 0 is equals to v square minus 2 a. What will be a? Mu g by root 2 x. From here x is equals to v square by root 2 mu g. So the d min is equal to d minus x, d minus v square by root 2 mu g, and that's the answer. The interesting thing to note here is that the path will be a parabola, not any other such kind of, one may assume it to be a straight line or a circle, like it will go like this in a circle, just what happens in a magnetic field when a charge moves. But this circular path is also not the optimal solution. The optimal solution in this case is a parabola. Hope you enjoyed the video. This was a rather a short video. Thank you. Have a nice day.